It is estimated that nearly half of the world's population was using the internet by the end of 2016. According to the European Commission, Europe's data centers will require 100 terawatt-hours of power by 2020. That's equal to 10 nuclear reactors. Digital technology is shaping everything from culture to industry. Making digital systems more energy efficient is vital. The EU Euroserveur project set out to do just that by developing new microservers for tomorrow's data centers. Cloud computing is made up of a tiered architecture using powerful single-core processors. According to a theory developed at EPFL, powerful single cores waste a lot of energy when they are taxed with numerous small processes, typical in the presentation tier. Scaling out, which involves distributing tasks over a large number of computing nodes, reduces energy waste. The Euroserveur project partners improved and implemented the theory. Not only did they replace the traditional presentation server architectures, these microservers could also provide an opportunity to move the presentation layer between users and the cloud, taking some of the burden off of the cloud and making new applications possible. Traditional system-in-package architectures usually include one or more large processor cores, a memory controller, an input-output controller, and interconnections. The memory is located outside the system-in-package. It is copied in part to the cache memory. When scaling out a server, a set of smaller cores, each with a very small cache, replaces each large single core. The memory plan is segmented, and each segment is logically associated with the processor core sets. Ultra-fast embedded data compression further boosts memory capacity. And, to reduce bottlenecks, the input-output interface is distributed within each cell in the form of a virtual interface. With this architecture, small cores can be associated with their dedicated memory controllers and virtual I/O interfaces in coherent units that can be built using unified or heterogeneous technology. These basic hardware units can be networked on an interposer or circuit board, for example. This tiled architecture can be repeated in large numbers distributed horizontally. For unified technology implementations, fabrication yields are higher for smaller components. So this architecture also provides a cost roadmap for several generations of technology. Because each unit is coherent, it is easier to develop a tailored microhypervisor. For times when more memory is needed, access to remote memory is possible using Unimen middleware. This also ensures that the scale-out works as intended. The new distribution is spread out horizontally over all of the nodes for a much more balanced allocation of resources. This design is good for managing a large number of isolated tasks and reduces conflicts considerably. Supported by new virtualization scenarios, the Euroserveur architecture delivered good energy performance for loads typical of cloud infrastructures and 5G telecommunications servers. So, the Euroserveur project has already generated real benefits. 2 startups have been established to develop and commercialize intellectual property created during the project. ZeroPoint Technologies will commercialize the effective and ultra-fast data compression technique. Kaleao developed a scalable microserver that uses the implementation developed under the project. The company has already signed a deal for 100,000 units.